Selecting the best external Thunderbolt 4 enclosure and SSD for your M4 Mac? How do you decide? Let's talk about it. Welcome back to the channel. So what I'm going to do in this video is I am not, N-O-T, in quotes, I'm not going to tell you exactly what Thunderbolt 4 enclosure or SSD to buy. I've done some videos in the past, check out my channel. I'm reviewing some new ones for future videos in the future, but this one's going to take a different course, but I think this is actually the most important way to go about it, to learn what you're looking for. So what I really wanted to do in this video is kind of show you a couple things and just make sure you understand that things are not always as they seem when you see tests online, like Blackmagic tests of enclosures like this over here or SSD drives. I mean, all these tests mean something, but it really comes down to the cable you're using, the SSD enclosure, the SSD drive, your room environment, your actual test setup, what you're doing in copying, all that stuff matter on how the drive is going to perform. So it's best to pick a setup based on some basic research and then test it in your real environment to make sure it works correctly. That's the most important thing here. I mean, it's really going to be, the reason I want to kind of go through this is it's more important to learn what you're looking for in these tests than to actually just have me tell you exactly which one should you buy. So I'm going to start off by showing you some tests to begin with and then some things to look out for. And by the end of the video, I'm also going to show you how I test enclosures, Thunderbolt 4 enclosures with SSDs, and how I do some tests to make sure they're performing well for me beyond just like Blackmagic tests. Like, what are the things I look for? How do I test them? What do I kind of compare against each other? So you guys can understand when you actually get one in-house and you test it, is it really working well for you? What are the tests that I go through? I want you guys to understand what I do. Okay, and also for starters, I'm talking about Thunderbolt 4 enclosures, not Thunderbolt 5 enclosures, all right? Thunderbolt 4. And I think most people can get away with Thunderbolt 4. I'm going to talk about that later in the video. Do you really need Thunderbolt 5? But let's get into that later. This is Thunderbolt 4. So what happens is people always ask me, I get this question maybe once, twice a week. People say, well, should I get a 7,000 megabyte per second, SSD or a 5,000 megabyte SSD? Does it really matter when I'm using Thunderbolt 4? Or, is it going to make a big difference? Should I get the fastest one possible? Is it going to make my Thunderbolt 4 enclosure speeds way quicker? And this is what I'm going to show you initially. This is the first question I want to show you. All right, for this test, I'm actually going to be using this actual enclosure right here. You can see down here I have a whole bunch lined up. I have about 10 more over there, so I have about 20 Thunderbolt 4 enclosures. I've tested a lot of these things. This is just for this test, all right? This is by Acasis. Look at my website over here, the page over here. It says Acasis 40 gigabit per second M.2. You can see it in here, it's $117.99. Kind of expensive, 12 bucks off right now, but I'm not telling you to buy this, so that would be like $102. I'm just going to use this as the test. I wanted to set the test up just from the beginning to show you which one I'm using, and I'll show you close-ups as I'm talking about this, but I just figured I'd pick one. One's better than nothing, right? I'll pick one out of all the ones I have here, and we'll start there. All right, for the first test, I'm going to insert a Western Digital Black SN770 SSD in here. Here's a picture of it online here. It's $69 for a 1 terabyte. I actually have it I'll show you some pictures of it in the enclosure. And I'm going to run Blackmagic on this, and let's see what this does. So what this says basically, though, right in here, it says it's rated for 5150. See right there? 5150 megabytes per second. That's what it's rated for. Obviously, you're not going to probably get that with Thunderbolt 4, but how fast is it? Let's check it out. All right, here's the test right here. Let me go ahead and show you what we see here. I'm going to go ahead and start the test right now. You can see that it's coming at 2760 on the writes and about 2819 on the reads. Let's just do this one last time. 2732 and about 2809 on the, the reads. So overall, not a bad score. Very consistent, very high. And actually, there's a fan on this thing. It runs pretty cool. So overall, I have no problems with this score whatsoever. It's a very, very good score for what it is, but let's just go ahead and test some other ones now. Remember, that was rated for 5400 on the drive, and we're getting about 2800. All right, the next drive I wanted to test is sitting right here. You can see it in my hand. I'll show you some close-ups of it. It's called the Orico. This, I believe, is the, the O7000 series 1 terabyte drive. And you can see here, it's $69 for a terabyte. It's rated at 7,000 megabytes per second, so roughly about 2,000 megabytes per second faster than the Western Digital. So let's throw it in the Thunderbolt 4 enclosure and see what we get here. Okay, here's the test here. We can go ahead and let this go. We're getting 2461 there on the writes. And on the reads, 2511. Let's just do this one more time. 2454. And then we're getting 2852. So you can see right there, right off the bat, that was rated at 7,000, and it's actually slower by a couple hundred megabytes per second on the Blackmagic test. And so that answers your first question. It doesn't always depend on the actual drive itself. It can depend on a lot of other factors, and I'll get into that in a second. But overall, just because the drive is rated really fast does not mean that it's going to perform really good in an enclosure like this. Okay, so just to drive the point home here, here's the third test here. This is going to be on a different drive. This is a budget drive. I'll show you pictures of it up close, but this is actually called, it's made by Leven. Here's the picture over here on Amazon. It's the Leven JSP600. This is a 2 terabyte. You can see it's $88 for 2 terabytes. That's not a bad cost, but it's a really budget drive. I'm going to go down here. What it says here is, this is kind of crazy. It says maybe up to 3,000 megabytes per second, at least 2,000 megabytes per second, whatever that means. So between 2 and 3,000 megabytes per second on this drive. So let's go ahead and test this one. This one's way lower than the 7,000, less than half, maybe less than a third of the speed on paper. What's it do in the Thunderbolt 4 Enclosures tests? Okay, so we have the test right here. Let's go over here and we'll see what it's going to do here. So what we're getting is we're only getting 1727 on the writes, and that kind of makes sense. But look at the reads. We're up to almost 2,800. So again, 2730. And then in the reads over here, 2783. So you can see that the reads there are actually just as fast or even faster than the other two drives for some reason. I don't know why. It said it could go up to 3,000. Maybe that's why. But then on the writes, it's way down. So again, you just don't get a good representation of how fast it's going to be in Thunderbolt 4 until you actually test it in the enclosure itself. And I just wanted to kind of drive that point number one. So the moral of the first story here, or the first thing I show you, is you don't always need to buy the fastest drive like I just said. And in fact, sometimes that can cause some issues, which we'll get into in a second, because it can cause heat. It can bring some heat into the situation. The faster the drive, usually the hotter the drive is. Not always, but sometimes. And then you have a harder time cooling it, which can make a big issue later down the road. So it can actually compound itself into issues if you have a really fast drive. But I'm not saying do it or don't. We're going to keep getting into this as we move on, and we'll cover more stuff here. But that's the first kind of lesson to learn. Another good key takeaway from my test in general is really the fastest performing drives I've ever found on Thunderbolt 4 are consistently between like 3,000 and 3,300 megabytes per second on the reads and writes. So if you have a drive anywhere in that range, and again, we're not only going to test with Blackmagic, I'm going to get into that in a second, but if you have a test somewhere in there, that's going to be about as good as you can get on Thunderbolt 4. You're going to see some kind of bursts up to 3,600, but it's not going to be consistent there. Usually 3,000 to 3,300 is what you're shooting for. That means you have a really good drive at that speed in that range there. But if you're only getting like 2,800 megabytes per second, don't sweat it. You're not going to notice the difference. Trust me, you're not going to notice the difference between those 500 or 300 or 400 megabytes per second. It's as long as it's stable and good at that point, just be happy and you move on. I mean, we'll get into if you need Thunderbolt 5 later, but trust me, for 99% of people, 2,800 megabytes per second is awesome. And if you're going to go up to 32, it's probably not even worth your time or effort. So just keep that in mind. That's going to be lesson number 2. Okay, now let's talk a little bit more about heat. Now, one of the questions I get asked, again, all the time is, I got this enclosure, they say, let's say it's a Satechi one right here, and it's warm to the touch when it's plugged into my Mac. It feels kind of warm, or sometimes it gets a little hot. Is that a bad thing? Now, first of all, let me just explain this. So you got to understand how sometimes these things cool. So there's going to be like passive cooling. It's a big block of aluminum, and it transfers the heat to the case. That's what you want. There's going to also be ones that have fans in it, like the Acasis one over here. But for the most part, just because an enclosure is hot on the outside, that actually could mean it's doing its job. Because if you think about it, when you put the enclosure in here, right, or the SSD in the enclosure, you're going to want to get some heat tape in there. And the heat tape should actually be touching the SSD and then touching the top, usually the top of the enclosure in those passive enclosures. What it'll do is it'll suck the heat out, and it'll actually go into the case around it. If you actually feel the case and it's freezing cold and it should be actually a little bit warmer, it may not be doing its job. You may not be touching the heat tape with the top of it, and that could actually keep all the heat in the SSD or in the actual chipset and stuff like that, which would slow it down even more. So just because it's a little warm or a little hot doesn't mean it's a bad thing. It actually could mean it's doing its job. A few examples of this is, here's one from OWC that does fairly well. If you take a look over here, it's $94.99 from OWC, but it's just a giant block of metal. You can see it's passive cooling. Everything gets sucked into this kind of cooling panel up here, and all of that heat will get sucked out. Things like that. So I also talked about this one over here. Actually, this is a little bit different than the one I have. I have a Quiz Lab, but this is more or less the exact same thing. The Quiz Lab actually sold out. It's right here, but you can see the size of this thing, and I'll show you down there compared to the other ones. It's just way bigger than the other ones. It weighs like 2 pounds. It's just a really big block of aluminum, and that does a good job of cooling. So that's not a bad idea either. The Satechi here is also another one here that's pretty big, but it doesn't have as thick of aluminum, and this one tends to get a little bit hotter because if you can feel it coming through the metal. So overall, these bigger ones actually are good in most cases. So one thing I like to say is if you're doing passive cooling on Thunderbolt 4 or Thunderbolt 5, in my opinion, the larger the enclosure, as long as you have the heat tape correctly in there, the better. So the larger the case, the more heat it can dissipate. So you don't want to go with these little tiny ones, especially Thunderbolt 4. They may look cute and stuff while you're moving around with them and going to the library and stuff, but they usually get really hot because they suck in all that heat, right? The bigger the better in most cases here. And that, you know, that's just the way it is. And with enclosures and heat and stuff and the way heat works. So just keep that in mind as another tip. Okay, so in the box of all these enclosures, you're usually going to get like this heat tape here. I call it heat tape or whatever, thermal tape. And you get these things. And in here, they gave me 2 of them, but they're really, really thin, like micro thin. So when you put these things into an enclosure, if it's just sitting on top of the drive, well, first of all, you want to peel off the plastic. Make sure you do that, all right? But if you stick this on them and it's just sitting on the drive, but not touching the top of the metal or not touching anything, it really just, the heat just stays there. So what I like to do in a lot of my enclosures is I kind of re-engineer the cooling of it, all right? So what I like to do is get bigger enclosures. I like to go out and buy some heat tape like this. Now, this is really inexpensive. You can see it here. It's $5, $6. But this is actually 1 millimeter thick. A lot of these pads over here are like 1/10 or 0.25, 0.5 millimeters. This is going to be a millimeter or even thicker. And I get it so that it actually can really scrunch down on the top of the case. It really touches it with some good force. Now, but the key here is the reason you want a big case is because you don't want to kind of stuff the tape in there and have all the room around it be taken up. You just want the space, you know, really kind of smashed down on the top of it. You want the air to flow around it. That's fine. And you want it to touch the top, dissipating the heat up. But if you put it into a small enclosure with a really thick heat tape and you squish everything down in there, things start to warm up. So I've learned that over time that bigger is better, definitely, on these faster enclosures. And getting some like third-party heat tape for $6, $7, $8, you can see the rating on here, 4.6. It just helps a lot. Now, all enclosures are different. I want to show you this, and things aren't always what they appear. This is what I'm going to prove to you by the end of the video. But here I have a Satechi enclosure, not the Acasis anymore, and I'm going to put the Western Digital SSD drive into here. Remember, we got like 2800 on the up and downs, read and write speeds, like 2900, somewhere in that range. I'm going to now put it into the Satechi over here, and we're going to run this test. Now, let's take a look at what this does over here. This is actually important. Look right here. We got 3670 now, and we got almost 3,000, well, over 3,000 to read. So let's do this again, 3763, and let's take a look, 3,052. So you can see it's a massive difference by putting it in a different enclosure. But what does this actually mean? Okay, before I answer that, let me just show you one more test here because this will kind of answer it for you. So what I did is I used that drive for an extended period of time, maybe like 20 minutes or so, and then I ran the test again, the Blackmagic test, right? And I wanted to see how it performs basically the second time. And let's go ahead and take a look here. So the second time I ran it, after it had some use going on, it was down to 3117 and down to around 3,000. So it dropped 700 megabytes per second on paper, right? But it really did. This is going to be the true speed here, around 3,000 megabytes per second, because when it's plugged in and it gets a little bit heated up, that's when you want to test it. So that's another tip here. Test after you do some use on it. Don't just plug it in and test it because it'll be the fastest at that point, but it won't be a realistic test. Okay, so if the Blackmagic test doesn't tell you the true numbers, and it's kind of, like I said, it can be all over the place sometimes, what is the best test to do? Well, what I do, in my opinion, is I always test a 100 gigabyte data transfer test. Now, a lot of people come back to me and they say, well, you should really do 2 terabytes testing and see if it heats up and slows down. I always tell people I only do 2 terabytes of data transfer like once a year, maybe once in my life. I'm doing like 100 gigabytes sometimes, or every so often, but I don't usually go higher than that. So that's what I want my drive to perform well for me, is a 100 gigabyte test. So that's kind of the test I came up with. I mean, I can deal with a little bit slowdowns at 2 terabytes because I don't do it that often. But at 100 gigabytes consistently, I want it to perform well. Now, when you're performing this test, a couple things to note. So let's just say 100 gigabytes I'm going to actually transfer, and we're going to do a test here in a second. But if I'm going to do 20 different files, I have 5 gigabytes each to equal the 100 gigabyte file. So I'm going to do, it's 20 files I'm moving for 100 gigabytes total. If you did 1,000,000 files that equaled 100 gigabytes, this test is going to take longer. I just want to explain that. So when you're doing these tests, be consistent with how many files you're moving, the size of them. It doesn't matter if it's 50 gigabytes, 100 gigabytes, but you want to keep 20 files or 30 files or 40 files on all your tests when you test these out. Don't do one with 1,000,000 files and one with 1 file, because it's going to make a difference. Okay, so now what we're going to do is we're going to do a 100 gigabyte test on the Satechi enclosure over here. Remember, I got up to 3,700, then I went down to 3,100 megabytes per second. We're going to use that enclosure. We're going to do a 100 gigabyte test here. I'm going to go ahead and start it here in a second. So if you look at my screen over here, I have 100 gigabytes. Again, those 20 different files. I'm going to drop it in here. Actually, let me get here. It took me about 2 extra seconds there, so I'm going to add 2 seconds to the end of this. But let's see how long this takes. You can see in here, it's now at 25 gigabytes transferred, 30 gigabytes. It's moving really quickly. So you're watching this move, and we're at about 11 seconds so far. And we've gone up to around, 51 megabytes per second already. So we're moving really quickly. This is the real test you want to see. Now, does it slow down in the second half or not? Let's just take a look here. So now we're at around 23 seconds, 24 seconds. We're going to get up. It looks like we're almost done here. And let's just see what it does here at the end. So right there, 29 seconds. So if I added 1 or 2 seconds because I was a little late, let's say it's 30 or 31 seconds total for that test. And what does that come out to, right? That comes out to between like that 3,100 and 3,300 megabytes per second. You do the reverse math on it. And that'll be a proven test right there. Don't worry about black magic so much. It does equal it in this case, but I've done other tests where it doesn't really match black magic that well. It definitely didn't match that 3,700 megabytes per second, but it did match that 3,100 megabyte per second test that we did the second time under stress and under load. So that's one of the best tests you can do. Now, one thing I do with that test as well is I like to measure the first half of that versus the second half. If you get a drive that's actually taking, let's say, 15 seconds on the first part of that, and then it takes a minute on the second half, you pretty much are guaranteed that that's heating up and having issues because over time, as the drive starts to heat up, it's slowing down. This one was really consistent. You could see it almost all the way through. It slowed down just maybe a couple seconds on the second half of the test, and that's actually a good test. Okay, so one thing you can grab from this video and kind of the moral of this whole thing is when you do these kind of tests, what you're looking for is somewhere between 30 and 40 seconds on that exact test. That means you have a performing drive between the 20-something hundred and the 30-something hundred megabytes per second, and then you're golden. Just walk away, you're fine. As long as it doesn't disconnect on you, which we'll get into, you're fine, right? That's kind of what you want. Now, whether it's 30 seconds or 35 seconds or 40 seconds, it's not going to make a major difference in your life. Trust me. You're not even going to notice it. And I can guarantee that. I've used hundreds of these things. You just don't even notice it. But what you really want to do is make sure it's not maybe 60 seconds or 90 seconds or 120 seconds, because then you're running into some major kind of thermal throttling, or it could be the chipset on the actual enclosure, or your SSD could be in trouble. There's a lot of things then you have to start piecing out what the problem is. But if you do that test and you kind of fall within that 30 to 40 second range and moving that 100 gigabyte of data, maybe 20 files in there that equal 100 gigabytes, that's a good test. Oh yeah, and one thing to note too when you're doing these tests is make sure that you actually your hard drive, your SSD drive, is about 10% filled on all your tests, depending if you're testing different SSDs, different enclosures. That'll give you kind of the best kind of idea of where you're going to be on performance. Now, if you fill it up, I like to do it at 10%, and then you can also do a test at 90% filled. At 90%, I guarantee it's going to be slower. But how slow is it? Is it going to be crawling at like 50 megabytes per second, or is it going to maybe go down to 2,400 megabytes per second? And these are some tests you can do in real life to kind of determine, is this a good setup? Now, I also say never fill up your drive to 90%. So if you're buying an external drive for an SSD enclosure, make sure you can always usually save like at least 15 or 20%. So buy big enough. If you buy a 2 terabyte, maybe only fill it to 1.7 terabytes. Give some headroom in there because these things do slow down. But testing both sides of that when they're filled and when they're not filled is important. So don't do tests against each other if there's 2 different filled up drives because they'll make a difference. And then a note, just because we were watching this whole video, I did the exact same test with this Acasis enclosure here. And remember on paper, the Acasis was way slower. But in reality, this came in at 35 seconds right here on the Acasis with the Western Digital. So it was like, maybe 4 seconds slower. In the scheme of things, after 100 gigabytes of data movement, 4 seconds, 1 second every 25 gigabytes, is that going to make a difference in your life? And then on top of that, believe it or not, the Acasis actually, to the touch, it ran a little bit cooler. And again, I don't know for sure, and I'm going to be doing this in future tests, but you have to really get in and actually measure the temperature of the SSD drive. That's important. You have to measure the internal temperature of the SSD drive, not the case. The case doesn't matter, like I said, because at the end of the day, it tries to get the heat out. It's really the SSD that matters. But this thing ran a little bit cooler. It appeared so. So would you rather have that versus speed, or would you rather have, this all comes down to what the thinking is behind what you should really buy. Okay, so what do we learn from this? Well, this can get really complicated. There can be heat issues. There can be a whole bunch of things going on here that you're not aware of. How filled the drive is. So I recommend this to a lot of people. If you're like a beginner user, for example, first of all, do you need Thunderbolt 5? I don't think anybody needs Thunderbolt 5 enclosures. Maybe for connecting multiple monitors and stuff. But for the SSD speed, I think 3000, 3300 is fast enough for everybody, editing, 3D modeling, you name it. So don't even worry about that. Don't get involved in Thunderbolt 5. I might do some tests later, but it's really not worth everyone's time and effort. Thunderbolt 4 is fast enough. And even if you're a normal, kind of just a normal user, just buying like a pre-built T9 or T7 by Samsung, an external SSD drive that's proven to work well, that's about 1,000 megabytes per second, you most likely won't even notice that. You can still do video editing on it. It's still going to work fine. It's probably not going to get too hot. So that might be the best option for most people, is just buy the slower speed. Again, the slower the speed, usually the cooler it is. The faster the speed, usually the hotter it is. You can get in some situations there. And everyone thinks they need the fastest drive in the world, but you really, really don't. I mean, most people will be hard-pressed to notice the difference almost everything between 1,000 and even 3,000 megabytes per second, because you're just not doing things that makes a difference there. Okay, so we're going to wrap this up. So when you are buying these things, just make sure you do the proper tests here. Don't rely on black magic. Do your 100 gigabyte data test. Test the first half, the second half. Make sure the file size is the same. The fill drive up is the same. Do all this stuff. Check the heat. Make sure the heat of the actual drive, not the enclosure. Don't take a thing on the outside of the enclosure, because that doesn't matter. These are all things you got to think about. And then make your determination and don't sweat it. I know this seems really complicated, but I'm trying to uncover it, and I hope you learned something from this. I mean, I do a lot of this stuff, and it's like, people ask me, well, which is the one I should get? And it's like, I don't know your setup. I don't know what you're doing. I don't know what you do. So I can't tell you. But at the end of the day, I try my best to at least educate people, and I'm sure a lot of people know more than I do here, but this is just what I've learned, and I hope you guys like the channel, and we'll talk to you in the next one. Peace.